Hello everybody. Now we will take up part 3 of unit 1, that is the solid state. In the previous part we discussed about the packing efficiency and how atoms in the solids are arranged in the three-dimensional pattern, and also we have learned about how to calculate density based on unit cell dimension. In this part, we will be seeing the imperfections in solids. Even though solids have great orderliness compared to liquids and gases, they also have some imperfections. If at all there are imperfections, what are the ways of imperfections possible? And types of defects in the crystal lattice, and also the properties related to solids. Now, what are the imperfections? Why the imperfections will come in the arrangement? As you know that solid gets perfect crystalline state at absolute temperature. That means 0 degree Kelvin. But solids are at room temperature, or they are prepared at room temperature. Therefore, they have some defects. So, some defects in the arrangement. They are also called thermodynamic defects. So, any deviation from perfectly ordered arrangement of constituent particles in the crystal lattice is called imperfections in solid. Suppose the atoms or particles in a solid are imagined like that, but due to imperfections, they may deviate from the ideal crystal structure. Now, what are the kinds of defects that are possible? The imperfections or defects are possible along the lines or along the points in the crystal lattice. If it is along the point, then it is called point defect. So, point defects arises due to the disorderness in the regular arrangement of constituent particles around a crystal point, around a lattice point. But in case of line defect, the defect arises along with the line in the three-dimensional space. So we have to discuss only about the point defects. What are the types of point defects? So point defects are majorly three types: impurity defect, stoichiometric defect, and non-stoichiometric defect. So in stoichiometric defects can be further classified into vacancy defect, interstitial defect, Frankel defect, and Schottky defect. And non-stoichiometric defects are metal excess defects and metal deficiency defect. So let us look into all these type of defects that are possible, point defects that are possible in the solid structure. What is that impurity defect? Impurity defect arises when foreign atom, different kind of atom, is at the lattice point of one crystal arrangement. So the host atom generates the impurity. For example, if you add strontium chloride to the structures of NaCl, sodium chloride, so strontium atom displaces 2 of the sodium atom because strontium is having 2 plus 2 as a charge, and so you can find the defect in the arrangement. So this is called impurity defect. So this leads to some cationic vacancies, and this is the arrangement. This is the arrangement that you can say. So here sodium chloride, so here is a vacancy. Here strontium is present. So these two are supposed to be sodium ions, place of sodium ions. These two are displaced by one strontium ion carrying 2 plus charge. So this is the impurity defect. Now We will see the vacancy or interstitial defect. Vacancy and interstitial defects are stoichiometric defect. So here stoichiometry is not being changed. Stoichiometry is maintained. That means ratio in case of ionic solids, ratio of cation and anion are as stated in the formula of the compound. Now this vacancy and interstitial defects are the defects found in metallic solids. Vacancy defects means atoms supposed to be arranged in order, but some spaces where atoms are not present lead to vacancy defect. So because of this, there will be the expected density of the solid will be less than the expected one from the theory. Interstitial defect arises when the atom which is not supposed to be there in the space, free space, that is being present. That means some extra atoms are present in the spaces or in the voids which are there in the crystal structure. This leads to interstitial defect, and due to interstitial defect, the density of the solid will be more than the expected one. So these are the one which is found in metallic solids. Schottky defect and Frankel defect, these are the stoichiometric defects found in ionic solids. In Schottky defect, equal number of cations and anions miss from the lattice point. So they go away from the lattice point. So vacancy defects of ionic solid decreases the density. Schottky defect decreases the density because missing of ions in that place, the volume will remain same, almost same, but the mass is going to be less. Because of this, density decreases. Right? So this is how it looks. Okay. So cation and anion, the place of cation is not there here. A place where the anion is supposed to be there is not there. Such kind of defects are seen in sodium chloride, potassium chloride, sodium bromide, silver bromide or so. Now Frankel defect. Frankel defect is also known as disjoint defect. Disjoint defect means some of the ions may be displaced. What we mean is this cation supposed to be in the place, but it is not at the place, but it has entered here, right? Leaving vacancy at its original place. It is supposed to be here, this plus cation supposed to be here, but it is here. So the mass is not going to be changed, but it occupies some places where the void is available. So this is also therefore disjoint defect. This dislocation leads to Frankel defect. So this Frankel defect we see in ionic solids where one of the ion is smaller in size. So this is shown by the crystals with the low coordination number. With the low coordination number and the large difference between the size of the cation and anion, which leads to this Frankel defect. So it is shown by zinc sulfide, ZNS, AgCl, AgBr and AgI. So note that AgBr is showing both Schottky defect and Frankel defect. Now coming to the non-stoichiometric defect, that is metal excess defect. In such non-stoichiometric defect, the formula of the compound is different. Formula of the compound is not actually maintained in the crystal structure. The ratio is not maintained in the crystal structure. The anion may be missing from the lattice site and the hole is occupied by the electrons that remains in the electrical neutrality known as F center. Okay, it leads to F center. Suppose this place where an anion should be there, say chloride ion, the chloride ion leaving its electron goes and occupies somewhere else. So it leaves an electron and gets the electron from the vapors of that particular atom. So this defect obtained when crystal is being placed in the vapors of that particular cation. So this leads to F center. F stands for Fabry colored center. This changes the color of the compound. The crystal becomes colored due to the excitation of unpaired electron, and when they absorb energy of the visible light and they show color. So excess of lithium makes lithium chloride pink. That means lithium chloride is placed in the vapors of lithium, changes its color to be pink. Potassium makes KCl crystal violet and sodium makes yellow. So these colors are due to the electrons and excitation of that electron and Fabry center. This is called Fabry center. The metal excess defect arises when the presence of extra cation in the interstitial sites. Okay, so this is metal excess defect. Electrical neutrality is maintained by the electron, but the cations are more than the anions. This is metal excess defect. Zinc oxide, when it is heated, oxygen atom combine together and leave away as oxygen molecule, O2 gas, and it leaves electron in its place, and zinc ions will be more than the oxide ions. Otherwise, ZnO, formula of the compound, the zinc ions, number of zinc ions must be equal to number of oxide ions. But because of the oxygen molecule go away by taking the oxygen atoms, the place where oxide ions were there, the electrons will be present. So this will give yellow color to the zinc oxide when it is heated. So this is also Fabry center. Now this is what the reaction is. The oxygen goes away, leaving behind 2 electrons. Right? So this is metal excess defect. Right. So let us look into some of the question which can be asked in the imperfections. What type of stoichiometric defects are shown by AgCl, silver chloride? When the coordination number is low, that means the large difference between the size of cation and anion there, it shows Frankel defect. So it shows Frankel defect. What are F center? F centers are colored centers formed by trapping of electrons, which are actually given by the anions in the crystal lattice. Right? So you can give rationale with some examples. Which crystal defect lowers the density of the solid? So the Schottky defect lowers the density of the solid. Also the vacancy defect. Schottky defect in case of ionic crystal and vacancy defect in case of metallic solids show such kind of defect. Okay. So which point defect in its crystal unit increases the density of the solid? Density of the solid when there is interstitial defect, it increases the density of the solid. Why ZnO becomes yellow on heating? So the same explanation just I have given is to be written in a correct order. Thank you. That's all for the solid state. Read and practice the questions which are being given there. Thank you.